So I prepared a bunch of slides. There's actually lots of slides. At the beginning, I have like a general introduction to the things that I see other people are doing as early career researchers. And towards the end, I think the purpose of the reason why I invited me is to talk about the stuff that we do. So we have a team of early career researchers, about 75 of them by now, and hundreds of students working together and trying to make a change in open science in the community. So I'll start by the generalized stories about early career researchers everywhere else, and then I'll focus on us. Like most of the things that I do, also presentations, everything is available for you to download. So there's lots of hidden slides. So you're very welcome to take this, download this, scan the barcode, and look at all the slides and come back to some of the information later on. All the talks that I give are on the open science framework. So many of them are about empowering early career researchers. So as you can see over here, I've given previous talks to like Oxford Reproducibility Club and all of that, but I do try as much as possible to talk to early career researchers because for me, this is the most important stakeholder in the science reform movement. I'm going to talk about a lot of things regarding open science and how early career researchers contribute to that. So typically when I talk about how embedding open science into early career researcher, the framework, I usually refer to these kinds of presentations, and many of them were given by early career researchers. So for example, here is navigating open science as an early career feminist researcher. And then we've got all sorts of tips on what is selfish about open science. So it's not only about contributing and sacrificing your career, but there's also things to be had by joining these sort of things. The Riots Club did some very nice things about open science for early career researchers. Max, which you mentioned, recently gave a talk at our Brown Bag where he talked about his journey as an early career researcher. So if he hasn't talked enough and you want to know more about what he did with us, then this is a good way for you to get to know our team and Max and what we've been doing together. I think also Dan Quintana is not too far away from you, right, in Norway somewhere. So I was trying to summarize all the early career researcher contributions that I've been seeing, and I even went on Twitter and ask people, maybe I've missed something, so I want to add some more. And this is a short list. There's like a longer list of things that early career researchers have done for science, for the science reform movement. And I will be talking some of this also from my own experiences. So for example, reviewing the PRO initiative, I don't know if you're familiar, but I'll talk a little bit about how I discovered out of nowhere that as an early career researcher, I have power to make a real change. Using our roles in ethics committees, our courses, and then a lot of things, contributions that we don't often acknowledge as much, like detecting and reporting fraud. Sometimes even it gets to, it backfires because you go against senior people with power, but all sorts of things, building automated tools. So I'll just start going through this. And the main claim that I have is that early career researchers can make a difference. They don't feel empowered enough, but actually there's lots that you can do as an early career researcher. I'm going to start from something that is not open science, because aside from this slide, everything is open science related. But I do have research interests that have to do with social psychology and judgment and decision making. And I think one of the biggest reforms in how we think of ourselves as social scientists, philosophers, social psychologists, behavioral economists, and so forth, is that we used to do our lab experiments and writing for our articles and all of that, but then a number of early career researchers from various places from around the world, so here you can see like Scotland and Australia, decided to start a movement. And I think the effective altruism movement so these slides or images are from the Center of Effective Altruism, that is now a very large movement that is handling billions of dollars, I think annually. And many of the prominent figures in this effective altruism movement are early career researchers. So for example, William over here age 35. But actually, if you see when he started 80,000 hours, this started a decade ago. So he was in mid-20s. I think he was in Oxford or something like that, deciding that as a philosopher, it's not enough that you reflect on the status of the world, but it's time that philosophers take action. Over here, we've got Giving What We Can. So started in 2009, so 13 years ago, from the age of 42, so also in the 20s, and really driving a big difference. And of course, afterwards, they have TED Talks and they have books. And through that, they formed the most unbelievable movement to drive a real change in society by philanthropy, giving, helping, but also with a scientific angle of being able to evaluate how do you know that you're contributing? How do you maximize altruism to make it effective? How do you make sure that you know where your dollars invested are going? So that's the one example that I have that is not open science, which I really recommend if you don't know the effective altruism movement. These are inspiring early career researchers that have decided to take a stand, drive change. I'm very involved in the replication kind of groups that are trying to go revisit, reassess, rethink classic findings. My own niche is social psychology and judgment and decision making, but there's now a lot of labs from around the world that have come together and have tried to do research together. It's interesting that up till 10 years ago, we didn't really know how to collaborate with one another. We were looking at CERN and physicists collaborating, but we didn't really know how to do these kinds of things. But because of the so-called replication reproducibility crisis, we understood that we need to put in resources together. We need to have well-powered samples. We need to have cultural diversity. And so we have a lot of amazing these kinds of collaborations from many labs, 1 to 5. Perhaps some of you have been related to that in some way. That has led to, revelations regarding the replicability rate, especially in the social sciences. But since then, many babies, many primates, many classes, EEG, many labs, and so forth. So a lot of collaborations, many beds that you can take part in and drive a change. Only recently, I think we started giving awards to early career researchers. So if you're not familiar with the Einstein Foundation Award, the first time was last year. Now they're getting new nominations. So if you feel like you're part of a group, an early career researcher that does remarkable things, you can get up to 100,000 euros, which is this kind of thing did not exist before. And honestly, I applied to this. Me and our team sent something in. But when I saw who won this, I'm completely, on board with this. They should have gotten the support. So many babies won this award, and I do think that they're doing some remarkable things because developmental psychology requires a lot more effort, and it's much harder to reach populations. And it's incredible the stuff that they do. Here you can see some of the other nominations. So the EEG many labs, a lot more resourceful. And a lot more labor intensive than what it is that we do, mostly on Amazon Mechanical Turk and all of that. So really remarkable things. And all of these are early career researchers. This is the Early Career Researcher Award. And with very, very little to no funding started and collaborated, just getting a lot of labs to coordinate with one another. Since we're here in reproducibility, I don't think you need an introduction to the early career researchers that started this. And now maybe they're not as early career. Some of them are progressed into assistant professor and are doing quite well. And that's very pleasing to see that there are some benefits to starting these kinds of things. But the scale of where reproducibility has arrived, to all sorts of different parts of the world. So it's really encouraging to see all of that. And I think this gave the motivation to other groups to form. So for example, the Riot Science Club is doing remarkable things. I watch almost all of their videos. I either commute and listen to this, or I watch the videos, and very engaging, very things that you can really learn from. And these were formed by early career researchers. So Sam is like coordinating some of these things, especially the head Rights Club. But by now you have so many Rights Clubs that all of them are doing these remarkable talks. So it's really nice to see the kind of impact that this is having, and recently also supported by an important UK group that cares about reproducibility. I think it's really mind-blowing, the kind of scale, reaching out and sharing open science driven by early career researchers. I think Psychological Science Accelerator also does not need a lot of introduction, but definitely in my mind, one of the biggest revolutions in psychology started by early career researchers thinking, why can't we do what physicists are doing with CERN? And the nice thing is that it doesn't really matter who you are, what stage of the career, undergraduate or not in academia, anybody can come and contribute. And there's so many different ways for you to take part. I mostly do data collection, but you can, go over protocols, or you can prepare code and clean data, or you can help draft the manuscript. So now, after many years of doing this, like 5 years already, 5-6 years that they've been running these, it's really nice to see that they have protocols and they know how to reach this. So if you look at when this started, it started from a blog post in 2017, and very fast it grew, mostly driven by early career researchers that were so enthusiastic about this, and then finally getting to some big prominent publications in big journals, Nature, Human Behavior. And I do want to emphasize here that being an early career researcher, open science, sometimes feels like a sacrifice. You don't really know, am I sacrificing my career? Am I going to be able to compete with other people who are not investing in open science? Maybe it takes longer. But when I joined, the only thing that I wanted to do is share for the community, so you can see my role was data collection, data collection, data collection. And when my department asked me, so where is all your science and nature publications? Why are you publishing in all these lower tier diamond access community journals? I think at the beginning, the first 2 years, I did not know what to say aside from this is what I believe in and this is what I think I should be measured. I should be assessed by open science practices and not by the impact factor of the entire journal. But I have to say that since then, an unexpected consequence is that if you join the Psychological Science Accelerator in some of these many labs, then at the end you will have a publication in PNAS and Nature, Human Behavior, and all of that. So that could be an incentive for you. Other groups that are doing mass scale replication are the CREP, and they're also been publishing quite a lot. So if you don't know how to get started with replications and you want to see with other early career researchers how to get started, how to be able to publish, you can join this. Plus, I like their emphasis, and we have a very similar emphasis to this, is that you can publish research as an undergraduate student. So we used to think of undergraduate students as, they come to our classes and we just bestow our truth upon them. We tell them what truth is, and they're passive receivers. But CREP, and in my courses, I've shifted the responsibility to a joint responsibility where both the students and I go embark together on a journey using problem-based learning approach for them to conduct research within my courses or through CREP in order to finally achieve a credible, high quality, highly rigorous project, a scientific project that can be published at the end in a journal. And I'll come back to how we do this. But I think this really was one of the first projects that said not only early career researchers, but also undergraduate students are stakeholders that we've been neglecting, and they're capable of so many remarkable things. Fort, for example, he's doing some big changes. So they've got these amazing, the glossary, I think, was recently published, I think in AMPPS or Nature Human Behavior. So 100 people coming together, looking at the Google Doc. It was amazing to see how everybody is building on top of each other. And within no time, getting a very high quality glossary involving many early career researchers. So most of the names over here, some of them are also in our team. So Mahmoud over here, Thomas is also in our team. So amazing PhD students, sometimes master students joining this and driving things, mapping replications, having an impact in terms of educational resources, summaries of research, and so forth. When I tweeted about this, I got a reminder. There's a similar group in China. I'm based in Hong Kong. Mainland China and Hong Kong are still, at least academically, seem to have different based on language. So we mostly do things in English, and mainland China mostly does things in Mandarin Chinese. But they have a very active group, lots of people involved in this, and occasionally we kind of interact. And you can see the scale and scope of what it is that they're doing. Some of it is translating from English, but some of it is adding their own into it. And almost everything in there is early career researcher based. Other groups that are in there, so if you're interested, you can go and have a look at this. Lots of podcasts that I follow. So if you think I can't reach others, I don't know how to communicate things, I don't feel comfortable with Twitter, I want to be able to discuss things that have to do with doing science as an early career researcher. So I love these podcasts. In judgment decision making, questioning behavior, they do a really good job at discussing behavioral economics and nudging and stuff like that. But there's also stuff about open science stories by early career researchers, and open update with Liberate Science. Very new podcast, Imposter Syndrome podcast with Sam from the Rights Club, Stanford Psychology, and ReproducibiliTea. They haven't posted in the last year, but when they've posted, I think 30 episodes, I used to follow this quite religiously to make sure that I'm up to date with everything they're doing. General claim, ECRs have power. I'll give you one example of how I discovered that I have power. And it all started with this paper in 2018 that said that if we want to drive change in journals embracing open science practices, I was very frustrated as a reviewer that I could not see the data and the code. And I never imagined that I, as an early career researcher, can do anything about that. I really thought I need to wait for the senior ones, the publishers, the editors, to decide that this is what they want to do. But interestingly enough, so Roger over here was the editor of the journal, or is the editor of the Journal of Experimental Social Psychology. Stefan over here used to be the editor of Psychological Science, so very prominent. So you have other big figures coming together and saying that we want to have an initiative where the reviewers, us, the people who are actually reviewing, are forcing the journals to change. And because most of the reviewers right now in science are early career researchers, postdocs, PhD students, I can't remember the numbers, but a very large percentage of reviewers are actually early career, because they are the ones that are willing to accept the invitations and have the time and the patience and the mindset for that. So we can use that kind of power. Reviewers of journal submissions wield considerable power to promote methodological reform, and they can promote the advancement of more robust psychological science and literature. How to do this? The basic claim was simple. You will not accept an invitation to review unless they make all the data and the code available, publicly available. And unless, of course, there's a justification, and then you can decide if the justification is warranted. You know, it's a good justification or not. I have to say, as an early career researcher, I was very scared of wielding this influence, but I decided, based on this, I will post on my website. So there's a reviewing section where I say what my research philosophy is also when it comes to reviews. So I always sign my reviews, even though I'm an early career researcher, because I believe in transparency and I believe that this is what needs to be done. I also try to contribute my reviewer time only to Diamond Open Access and the community journals. But here I added a sentence saying, I support the PRO initiative. I will only review submissions with shared data and code if authors have a good justified reason for not sharing their data and code. That's completely okay. There's other reviewers in the world. I would just rather invest my time in those that can share theirs. The first time that I actually did this, so in 2017, I received an invitation to review. So this is the European Journal of Social Psychology. Please review this because you know some stuff about free will beliefs. This is what I did my PhD on. And we had an editor. I was not familiar with her, but that doesn't really matter. And then I decided, so I got the invitation, I opened the manuscript, and I saw that they did not have open data and code. And I was very hesitant, should I contact the editor or not? And then I just decided, instead of telling her I will not review this, I said, I will review this, but then in my recommendation, I will say that I'm only willing to review the revision if it has open data and code. And then I really liked it that the editor said, please, as Gilad suggested, I think you should provide more information, how everything was determined, and some methodological information. And then this is what I wrote. I really just have one general request for the authors and the editor. I am part of the PRO initiative. I decided to do this round, but please share all your data in the code. And then I had a bunch of open science requests. And that was very difficult for me as an early career researcher because I did not know what the reaction was going to be from the editor and from the authors. And then the most important thing is that I urge you to share your data set and code. And then I understand how some authors might be hesitant, but my experience is that the community benefits from this. Then I got the invitation to review the revision, and to my great surprise, I saw that what they wrote is on their cover page as a response to my request is data and materials are available upon request. And then I said, okay, this is where I draw my, this is my red line. I will not cross this line. This is not acceptable to me. So I said, I wrote to the editor and saying, as the editor in charge, I am now requesting, I am forcing, as the reviewer, I want to see the data in the code for me to be able to say anything about this. And then somehow I was able to deduce who the authors were, even though it was anonymous. And then I also wrote to them and I said, you know, for some reason you decided not to share this, even though I requested this. Please do share, otherwise I can't really contribute to this sort of thing. The response from the editor was very nice of you to request all of this. We understand that you care about these kinds of things, but we can't change the journal policy now just because of you post hoc. And then my reaction to this was, I would therefore ask to withdraw as a reviewer. And not only this, I wish to withdraw any support that I have to publishing this manuscript. And I have to say, my hands were shaking as I was writing this and sending this. It was very difficult for me to do that. And I didn't know if this is going to backfire when I'm going to do this. Next time I'm going to face this editor or maybe these authors. Now I know who they are. So I was kind of scared about this whole thing. And amazing, this was like January 2018. So February 2018, a month later, suddenly, European Journal of Social Psychology has a new policy. And the policy is openness about research transparency. So many of the requests that I had are now embedded within the submission guidelines. And then you have to provide a working, publicly accessible link to the research materials and or data, and or explain why you're. So suddenly, the PRO initiative is part of the European Journal of Social Psychology. And my understanding is that a lot of early career researchers were repeating the same kind of things. And the editor just, you know, they got tired of this. So they said, okay, so now we're just going to make all the submissions this way. So this is a good example of how early career researchers can influence journal policies. But then even bigger than that, to my great surprise, although I withdrew, I went to see, you know, when they published this, finally, I went to see what happened with the project that I withdrew from. And then I saw, oh my God, they shared everything on the Open Science Framework. So that's amazing. So hooray for a PRO initiative and open science. So it's kind of like a very brief story about what it is that I went through. Maybe before I show some more cases, do you have any questions or things you want to talk to me about what I just shared with you?
I might have a thought or a comment to start with. That was really interesting little anecdote about using your power. And I think, so obviously for us working in health research, making your data publicly available is sometimes not allowed, which I guess is that's a valid reason. But even when it is allowed, now I'm thinking about the code. So for example, our code. As an early career researcher, I personally feel quite embarrassed, let's say, about my code. So I don't feel like I'm at a point yet where I can confidently share the code for everyone to see. Do you have some tips for that or some thoughts around that?
I can say that my mindset about this completely changed, and I gave a talk about this last week. So University of Vienna invited me to talk about the topic that I was talking about is check me, replicate me.
Mm-hmm.
And I was trying to give the example of why it's really important that we share everything so that others can help us do better code and check what it is that we've done. So I reviewed a few examples of people who discovered 20 years after their publications, after all the TED Talks and the books and the talks that they gave and, lecturing about this, and now it's in all the intro, that they've done a very simple statistical mistake that completely reverses the conclusions of the research, which could have been caught if they would have shared earlier. So it took 20 years for us to develop the statistical methods to deduce what it is that they've done. But the last thing that I want is in 20 years to suddenly discover that somebody developed the statistical method to see that I've made a mistake, and that everybody who has cited me, everybody who has invested their time, their PhD, research funding, taxpayers' money into something that I made publicly available, that I announced to be in support of some phenomenon or evidence, that this was false. So this terrifies me. It doesn't terrify me that somebody sees my bad code. It does terrify me that I have a mistake that will remain hidden for a long time. And then once, after a long time, I would see that a lot of money has been wasted. People have tried to implement policy, if it's health, psychology, or health related stuff, that some decisions have been made based on that when I had a mistake. So for me, my decision was exactly the opposite. So when I saw these kinds of case studies, for me, it's like, I want to get everybody on top of this. So even if I have bad code, it works, I have bad code, I want to get everybody on top of this to make sure that my code is good. And I now on my website, the Check Me, Replicate Me, I will offer money to people who will help me find mistakes in my code or help me improve the way that my code is, because whatever money I'm going to pay out for my own salary now is nothing in comparison to a mistake found 20 years later with all the implications that this has. So I have a bunch of other case studies from both me and some other prominent researchers about why this is important. In regards to the first point about what do we do when we have sensitive data, so I mentioned Dan Quintana is also relevant here because he has some really good guides, videos on YouTube where he talks about how you can do synthetic data sets. So you can have all the properties of a certain data set and make, simulate data that is as close as possible to that, and then have an external person that will look at both of these together and say, yes, I validate that these two are similar. And now we share the synthetic data set, and this is what everybody can work on when they want to reproduce this. So there are ways of us overcoming the problem of the privacy, anonymity, in order to share as much as possible. And if there's really something very, very extreme, then at least having a limited group that has, I don't know, an ethics committee or whoever, some access to that. At the very least, let's say an editor and reviewers. But this trust system that we have now where nobody has any access and we just trust the authors to, I'm not even like saying fraud or anything like that, but just to be perfect humans where they don't make any mistakes and they've checked everything. This is just not trustworthy science. So we need to come up with things like what Dan Quintana is advocating for. So if you have some issues, now as an open science community, we've come up with tools to allow people to make the most and to be able to share that publicly so that we can reproduce this, we can assess this, we can make sure that it doesn't have any mistakes, and we can build on that for future research.
Yeah, that's very convincing.
Okay, good. Should I continue? Yeah, I'll do a bit more. I don't know if you're familiar with Stuart Ritchie, but when we talk about social psychology and where the replication crisis started, I date this back to 2011. So BEM, in 2011 published in Journal of Personality and Social Psychology, which we in social psychology think of as a prominent journal that all of us want to publish in. So he published evidence for precognition, that people can feel the future. People react in advance to something that will occur in the future. We were all very puzzled by how this was published in the Journal of Personality and Social Psychology, because this is an impossible finding. But he used best practices, statistical methods to show that this is possible. So Stuart Ritchie, who's no longer an early career researcher, but back then definitely, decided that he wants to try and replicate this, failing the future. So 3 unsuccessful attempts to replicate BEM's retroactive facilitation of recall effect. Now, he talks about all his journey, about how he tried to publish this in JPSP after it became very clear that this is not reproducible, this is not replicable, and we can't, there's no chance that this holds true. But JPSP, at least with Stuart, decided to reject him. And he published this later in PLOS1. Now we regard PLOS1 as a given, but in 2012, people didn't know what to make of PLOS1. What is this journal? What, they publish null findings? They publish replications? What kind of a journal is that? But now, of course, we understand that we need that. Only in 2012 did they publish in JPSP a replication of BEM 2011, but it's still out there. So in 2008, it still gets cited as evidence for precognition. Last year, Stuart Ritchie came out with Science Fictions. If you haven't read this, it's an amazing book about the open science movements and the need to do more replications, assessments, and to clean the literature from all sorts of things like BEM. So you can also see him in a video over here. So you can raise questions about published research. You can try and replicate this, and then you can even write a book about this or advocate for open science. And he's been doing very well since. And I think the Science Fiction has got like a wide audience that helped the public understand a little bit more about the things that we're facing right now in science. More serious than BEM precognition 2011 is exposing frauds. Almost all the people exposing frauds were early career researchers, which is amazing, given that they have a lot to lose. And I think this is why many of them don't speak up. The most famous case study, I think everybody in Europe is perhaps familiar with Diederik Stapel in the Netherlands, Tilburg. So very, very curious case. He wrote a book about why he did what he did, and Nick Brown translated this from Dutch. So if you want to read this from the mind of the fraudster, you can go and read this on this website over here, Faking Science, a True Story of an Academic Fraud. And he's been giving TED Talks. I think he's kind of proud of the fact that he owned up to it. And it's it's an amazing tale. If you want to hear the story of the early career researcher, so he was a postdoc at Tilburg University. Now he's, I think, an assistant professor or associate already in the University of Toronto. So another podcast, Yoel Inbar. Back then it used to be Michael Inslet. I think now it's Alexa Tollett. So what is that they do? They have 2 psychologists. Each one has 2 beers. So they open up a bit, they crack a beer, and then they talk about personal experiences. So Michael Inslet used to talk about his big disappointment with ego depletion, not replicating, and all the consequences of that. But heartbreaking story about Yoel Inbar coming into Tilburg and talking about meeting Diederik Stapel, where it became very clear that everything is just impossible perfect. And at some point they trapped him, and then he came up with something that was just inconceivable. And this is when all the house of cards collapsed. So fascinating stuff. Go and listen to this, Yoel Inbar, early career researcher. Since then, we understood that we need more tools to expose fraud. So now we have StatCheck and Sprite and Grim and Grimmer. So all these were developed by early career researchers. So for example, Nick Brown, same Nick Brown from before, and James Heathers published this Grim test. So very simple technique to detect all sorts of problems with published research. And they give a bunch of examples of how can you just look at a paper and see that it doesn't make any sense. Not even fraud, but just seriously serious mistakes that are in there, maybe bad copy paste. But now we have simple tools where you just plug in the statistics from a paper, and then it can give you some indication whether something is off. Another case study with Tim over here about the one zinc case, where he just put all the papers together and looked at duplication and impossible findings and using all sorts of tools in order to expose a fraudster. I will not go into this, but it all started from a blog post where this person was giving very bad advice to graduate students about how they should p-hack. Since then, people are like, really, this is how you do research? And they started looking at his research, and then they saw all of this happening. And then it led to him being exposed as having very problematic research practices with shoddy data. And finally, he was fired from Cornell. So you can see everything Nick Brown and Tim over here and Jordan published this finally, the whole story about, we call this the Pizzagate. But by now, I think retractions are something like 40, 50 page papers. I can't even remember how many. This was from a while ago, but he has 52 publications that have some problems. All these amazing detective work was done by early career researchers, leading to all these big headlines about how the Cornell food researcher, basically did questionable research practices bordering on fraud. So this is Nick Brown over here. This is James Heathers. If you're not familiar with them, go and listen to them. And the community responded to this, especially the senior researchers responded to this as methodological terrorism, or they call them the data thugs. But this was 5 years ago. I think by now we all understand that we need them. So they were the first, as early career researchers, saying that we want to clean up science and we're willing to give up our career. You can see, Nick Brown is not young anymore, but he gave up his industry job to begin a PhD, and he did as his PhD, I think it was already 50 or something, to do detective work and be a data thug together with James Heathers. And James Heathers, I don't know if you're familiar with this podcast, but Everything Hurts. So Dan Quintana with James Heathers, this is where they summarize James Heathers' journey in exposing the Pizzagate and many other things in questionable research practices. So if you want a bit more of, I think the Riots Club did, Neuroskeptic recently gave a summary of the Brian Wanzik case study. More on exposing misbehavior. So once again, Nick Brown decided to do an analysis of some editor of one of our most prominent journals, so Perspective of Psychological Science. There was some Twitter post saying that this person just writes editorials where he cites himself. So Nick Brown just sat down and started coding, how much does he cite himself, and do some analysis, and then finally leading to the result that a prominent editor, one of our biggest scientists, was forced to resign. So you can see how fast this evolved. Blog post about Sternberg's self-citation practices, and then a whole team that identified this problem, and then finally leading to a resignation. So you would think, early career researchers by themselves, if they would try to do something, they might get hurt. But when we collaborate, when we coordinate, when we expose these kind of practices, early career researchers can really drive a big change, like replacing an editor, a very senior editor with a lot of citations and a big impact of one of our biggest journals, to replace him with somebody who's more trustworthy. Amazing tools. So Michelle over here with StatCheck. Now there's this app where anybody can upload a manuscript and check all the p-values. P-Checker is this amazing tool. You should go and check this out to summarize, p-curve, z-curve, all sorts of things to check published literature and see whether it's credible or not. Daniel Atkins, no longer an early career researcher, but I did a postdoc in Maastricht University 2016, and I used to go up to Eindhoven and listen to him while he was still a beginner assistant professor, and he did these Coursera courses, and he did all sorts of things like primers and reintroducing equivalence testing to social psychology, and really driving a change in social psychology as an early career researcher. So a lot of really interesting things from Daniel Atkins. If you want to see on the software side, so Jamovi is this remarkable revolution I do with my students, replacing SPSS So Jamovi runs on R, exports syntax to R, but it's still dialog boxes, click, point, and run an analysis. So it's better than SPSS. It's more reproducible than SPSS. It exports to R, and it's a community initiative. So the Jamovi team, Jonathan Love, gives a lot of love to the community. You can also build a transformative journal, so meta-psychology, started by early career researchers. Most of the team are early career researchers. So definitely the highest impact, I think, in open science, and I'll show you evidence for that. So they do things like open peer review, statistical reproducibility. They check for each publication that it meets the standards of everything in the manuscript, meets the data and the code. They have a very strict transparency policy. They publish no findings and applications and all of that. And you can see that after top factor guidelines were introduced, that meta-psychology is the highest. It's the #1 on the top factor, means that it has the most strict, highest standards of open science, really leading the entire domain. And all of that are early career researchers saying, enough with these journals not implementing open science. We're going to do our own with an open infrastructure. Diamond access, you don't need to even pay to publish. So I think that the conclusion from all of that, I just wanted to show you that early career researchers, if you have a feeling that students and early career researchers cannot drive a difference, most of the remarkable things that the science reform movement have achieved in the past decade were driven, led by, involving early career researchers, and the impact. But now in social psychology, there's no way back. You know, we're on a very clear path, and all this are early career researchers.
Mm.
If you know, so early career researchers have less of baggage coming in, but with that said, we need to really give them the credit for having the courage and the initiative to do all of that, because they, at least inherently in the system, don't have the power. They don't have the funding. They don't decide on promotions. They don't decide on what gets accepted to journals. So if you're an early career researcher and you want to ensure that you have an academic career and you have an academic salary, I think the easiest option is follow the status quo, do what it is that the senior ones expect you to do, just maintain things as they are. You need a lot of courage in order to be able to stand up and saying, something here doesn't make sense to me. I want to drive a change and to do something about this, regardless of criticism and pushback from senior researchers, top down rather than bottom up. But very, very few of those, not enough of those. But we don't need to wait for them. We can do things on our own as early career researchers to drive the change. My general recommendation is to choose an advisor that would allow you to at least have the freedom to pursue your own directions regardless of them, if not to be aligned with this sort of thing. But of course, that's not always possible. So we need to be realistic about these things. But my general recommendation when it comes to career in general, try and collaborate as much as possible, at least involve yourself in other collaborations. So you can perhaps convince your principal investigator, the professor that you're working with, you know, if we join Psychological Science Accelerator and we just, you know, participate as one other lab, then we can have a publication in Nature Human Behavior, in PNAS, in Perspectives, and all of that. And through that incentives, which I think many professors are aligned with, you can get them to see a little bit of what's happening within that team, endorsing open science practices. I think many of these reproducibility clubs or rights clubs help early career researchers kind of air some of the issues and how to address the professors, how to discuss these kinds of things with them. And also, I think a general strategy is to, you know, you don't need to come from the beginning and go from 0 to 100%, you know, everything now open, everything now pre-registrations, but, you know, one project at a time, adding one thing. And I think most of the time it's, you know, if you come to the professor and say, can I do a power analysis? And this is how it is. And I think it's going to improve our methods. Or can we have code review, somebody else going over in order to make sure that I'm not making any mistakes, or maybe sharing this aspect of our decision in how to do things in the process. So small steps, and then finally, after 2-3 years, you'll reach a point where the entire lab is perhaps having more open science practices. I've been doing this since 2017, so 5 years now, and I'm still learning. So I'm still, picking up more practices and trying. So now this year we're very devoted to registered reports. So up until now, it was difficult for us to do registered reports. I think especially because of the time that it takes to do things. And I'm doing most of the things with 1 year MPhil, 1 year thesis students, or 1 semester course students. So it's very difficult to do that if you have registered reports and you can't proceed to data collection unless you have an in-principle acceptance. But now we have these peer community and registered reports where they guarantee a scheduled peer review, a registered report review within 2 weeks. So suddenly I'm able to do all of my guided thesis students' work as a registered reports with a publication in mind. So for me, I'm learning so much by doing this, communicating with Chris Chambers and seeing the reviews, which are mostly open science folks. I'm learning, the students are learning, and this is one step beyond what we've done before. So each year, each project, you can add one small thing. I think it's much easier to digest for the senior scholars if you come at like a more structured approach. And then by the end of their graduation, or PhD, by the end of your postdoc, you'll have a list of things that you were able to implement, even with a more conservative senior scholar, if that makes sense. But yeah, it's a big issue. I know the problem here. Yeah. I think the biggest revolution that I see in publishing and the scientific process is really registered reports, because it also talks to the incentive of you can have an in-principle acceptance of the pre-registration plan prior to any data collection. So, before that, we used to complete our manuscripts with data collection and then start, let's try this journal, okay, rejection, another journal, revise and resubmit 1, revise and resubmit 2, and then rejection, and then you move to the third one. And you get this really hostile reviews of you did this mistake and you've done that mistake. So rejection rates are by the 80-90% in the journals, and then hostile reviews, and you feel like you've made mistakes and there's nothing that you can do about this. So registered reports really transform everything, where rejection rates drop from about 80-90% to 10%. And then you can work together with the reviewers, because whatever criticism they have, you can do this together. You can work on this together for you to actually improve. And then finally, you get an in-principle acceptance, typically in the first journal that you submit to. So it removes all the uncertainty, and then everybody benefits. Your professor benefits, you benefit, science benefits, because there was a pre-registration plan. And then finally, we address all sorts of science biases in terms of hindsight bias, outcome bias, and so forth. And this happens relatively fast. So now, at least with that, we're really improving. But there's also a case to be made about sharing data in code. So now we have meta-scientific evidence about how this leads to more citations and definitely to more collaborations. I get a lot of invitations now to collaborate because we've been sharing everything. So for example, I'll talk about our team and what we do, but we've completed about 120 replications of classic findings in the literature. Now I do everything with preprints because I get amazing feedback from the community. Sometimes I find all kinds of mistakes. Sometimes, senior people contact me and give me some constructive advice, and people want me to collaborate with them based on things that I've pre-printed. And I think for almost every open science practices, we now have meta-scientific evidence to show that this helps also, not only science, but also the researchers. You can put this on your CV, and the people who want to hire you or that you're applying for know that this is coming, and perhaps it will even be in their name, under their affiliation, when you actually get the acceptance. Plus, It could also be that, and it happens. So for example, there used to be, I don't know if it's still active, like study swap, or once you have an in-principle acceptance and you make this public, sometimes people will help you with funding or data collection. So register reports is really a revolution. Once you have an in-principle acceptance in hand, it's easier to get hired, it's easier to get funding, it's easier to convince people that what you're doing is credible. So a lot of advantages. It's really a revolution. So this is our team. I never imagined that it would be like this. So yeah, you can see it's from a lot of different countries around the world, around 75 early career researchers. We have a lot of lead authors, and I'll say a little bit what that means. And we also have a role of peer reviewer if you just want to be a peer reviewer. I have about 36 guided thesis students that worked with me, and about 370 course taught undergraduates. This is what we do. Within one semester in my courses, we complete an entire replication and extension of classic articles in judgment decision making. Typically, we have two teams of two students working independently on the same target. They start with a Qualtrics survey. Qualtrics has this function of randomly generating a data set. So they write the data analysis code with R or Jamovi on the randomly generated data set. We have a template for a pre-registration report. You're very welcome to use that. It's very, very elaborate. So it really helps them do this step by step. There's also a very detailed guide of how to do this kind of thing. Then once they have their first pre-registration report with the data analysis code on the randomly generated data set, we mix them. So they do peer review on one another. So this team reviews the other team. Each one reviews the other's documents and code. Plus, I go on Twitter and I communicate, this is what my students have done, who wants to help. And to my great surprise, a lot of people do want to help. So they go in, everything is Google Docs, so and open, so everybody can go in and comment what it is that they want. So we have peer reviewer from the students, they review each other. We have TAs, myself, and the Twitter community coming in and giving feedback. And then they have 1 week to revise. And then I have 2-3 weeks that I don't really sleep very much, where I do the pre-registrations for all the students and I collect the data on Amazon Mechanical Turk. So it comes in within a day or two. Then I give them the data set, they analyze this separately, then they do peer review on one another, then I get the Twitter folks. And finally, at the end, one semester, we have an APA style submission ready manuscript that ideally we can go and submit to a journal. We don't submit this to a journal. This is where you, if you're an early career researcher and you want to join us, this is where you come in. You can go and have a look at all the students' work and then decide if you want to join that. If you join us, you become the lead author, so first author, and then followed by the students, followed by the TAs, and then me trailing at the back, where you and so the early career researcher and the students are shared first co-author. And then we try to bring this together to a journal. The role for the early career researcher is to validate everything that the students did, because it's very possible that there were some mistakes in there. So that's an added layer. Add some analysis. Let's say that you're a Bayesian and they did frequencies and you want to add something. That's terrific. Make the introduction and the discussion stronger, or make sure that it fits with the data and it's humble enough. And then, of course, responding to the reviewers and making sure that it goes all the way. And as I mentioned, in the last semester, in the last year, we've been doing mostly register reports where we're submitting together the register reports. So the first 2 years we did this with data collection, and now we've been moving more towards the registered report version, but then you can just take over this stage before data collection. So after 4 years, we've completed about 80 with data and about 40 register reports. And we have about half of those are still not published. So you're all welcome to check everything that we've done, see what suits you. And if you want to take a lead, I have not said no to anybody yet. So anybody who wanted to join could have joined. If you want to see how good these things are, you're very welcome to press on this link and see everything is open in the spirit of open science. So this is 2019, has data collections. So we have two teams. So one team was Amazon Mechanical Turk for Americans, and the other team was British folks on prolific academic. And almost every time it was very consistent results. So you can go and have a look at this, and about half of them are already published. register reports from 2020, register reports from 2021. And if you want to see the kind of impact that this is having, I never imagined, like when I started this, I thought, this is kind of like a sacrifice. Nobody would want to publish replications, but things are changing in social psychology. So now you can really see the kind of impact into 2021. As you can see, this is what our team was able to publish. I was even surprised, like economics journals and all sorts of reputable journals in social psychology. Some of them are open science, meta psychology, and all of that. And as you can see, the model is that the first author, the italicized ones, are early career researchers. All of these underlines are students, followed by teaching assistants, and then me trailing in the back. And everything, of course, is open science. March 2022, we've got a bunch of those. And now in process, we have about 16 scheduled peer community and registered reports that I'm doing with all of my thesis students. So by the end of the year, all of these hopefully will also be in principal acceptance or already completed. All these are theses completed as a registered report. Now, if you don't, hearing this from me, that's okay, but you're interested in the early career researcher perspective. So I've asked an undergraduate student and a master's student to reflect on their journey leading to a publication. So actually Nadia has 2 publications already. She took the course with me, and then she joined me as a thesis student. So now she has 2 publications from that. So she shares her journey in open science. Cora over here did she was one of the first to work with me on these things. A very, very good replication that eventually was published in a journal. Some more student perspective, early career researcher perspective. Max over here, reflecting not only in a YouTube talk, but also on Psychology Today. We have a column. So you can see Hero and Max talking about what it means to work with us and our team. Adrian over here has done so much with us. So not only are we doing replications, but we're also doing meta-analysis and novel research. And the nice thing about Adrian is that not only is he doing all those things, but he's also helping us build templates. So now we have a template, an amazing template for doing a meta-analysis, so as a registered report. So if you want to know how to do a meta-analysis as a registered report, then Adrian has an amazing template for you posted on my website that me, Adrian, and Kit did together. So we have one for experimental and we have one for correlational. Amazing work with Adrian. So he's one of our more active early career researchers in the team. So this is just like a summary of how, the message that is in all these videos and our work with the students. So you have the power. We don't need to wait for senior researchers. We have very little funding, but we were able to achieve all that and work together, the 75 early career researchers, to have this kind of impact. It's easier than you think. If you don't know what open science is or you want to learn, just join our team, take a lead on something, contribute to one of our guides, examples, templates, and then learn from that by interacting with other early career researchers. We don't have any hierarchy, so we all just try to collaborate and do the best that we can and bring our work finally to submissions. If you want to hear from me 3 hours of what it means, what we've done, the 3 years of 100 replications, this is the YouTube. This is reproducibility in Oxford, the 40-minute version. And this is, if you want to know how to join us, this is a Google Doc of about 40 pages that talks about all the things that you can do in either taking a lead over a completed replication or taking a lead over a registered report, or just helping us with the primers. Perhaps you want to be a peer reviewer and you want to take a more passive, you just want to learn more and see what you can contribute. So whatever the level of involvement you want, you can find something to do in our team. If you want any information about what's available, we have a mailing list, and then all the talks, all the preprints, all the resources that we published are over there. This website summarizes everything about our team, who is in the team, what have we published, where is everything, what's to come. If you want to talk to me, I'm very active on Twitter, so that's a good way to reach me so that we can communicate all of us together as a community. But if you want to talk to me more personally, then I'm very happy to talk to you on email. reach out to me and just tell me how I can help you do better with your open science practices.